In this video, what I want to do is go through the examples from the guided notes for section 7.4 using Desmos. As a quick disclaimer, Desmos is one of the most phenomenal tools we have out there. It's amazing. It's free for everybody, okay? It can do some of the coolest stuff imaginable, okay? Like I wish when I was a student that I had had Desmos, okay? I didn't. I'm old. Okay. With that said, Desmos can be overused by a student. Okay. If Desmos is doing all of the work, then you're cheating. You're not earning your grade. Desmos is. You still have to be able to do your work on paper. For this class, I want you to use Desmos more as a way to just check your results. Okay. Please keep that in mind, okay? So for example one, we were just graphing single linear inequalities in two variables, okay? Our first example was 7x minus 5y is less than 45. Our method to solve this was to solve it for y. So solve the inequality for y. We ended up getting y is greater than 7/5 x minus 9. Remember, we had to reverse the direction of our inequality because we divided the entire inequality by -5. We got that we had a y-intercept of -9 and a slope of 7/5. We used a dotted line to connect our points because we had a strict inequality, and we decided we needed to shade above the line because we tested the origin, okay? So we looked to see what happens when we plugged in 0, 0 for x and y, okay? We got a true statement that told us to shade above the line. Let's see if Desmos can verify our work. So here's Desmos. Okay, the cool thing about Desmos is you can just type in the equation like in kind of, or the equation or the inequality in more of like that standard form where the x and y are on one side, the constants on the other. You don't have to solve it for y. So we had 7x minus 5y was less than 45, and there you have it. So you can see pretty clearly we've got our y-intercept of -9. We have a dotted line. We clearly have a positive slope. If we were to go up 7, all right, and to the right 5, let's see, up 7 and to the right 5, we would end up at another point on the line. Okay, we shaded above the line. All right, now let's say just for fun that you wanted to verify that you had solved your inequality correctly. Remember, we solved it for y initially, and we got y is greater than 7/5 x minus 9. It's exactly the same line. So we solved our inequality correctly, okay? So you can use Desmos really, really quickly. Notice our y-intercept, our slope, the dotted line, the shading above, it all verifies what we did by hand, okay? Now for example 1, part B, we had 3x minus 5 is greater than or equal to 7. Okay, now you can do the greater than or equal. There's like a little toolbar that you can use in Desmos that will do that for you. You might be able to type in a greater than and then an equal sign on the keyboard. I can't remember, but let's not worry about that right now. Let's do, what was it? 3x minus 5. And then down here, there's this little icon for a keyboard. Click that, and it will have an option for those or equal to inequalities. So we had greater than or equal. And then 7. And you can see right here, we've got a vertical line that goes through 4 on the x-axis. We shaded to the right, and we used a solid line to connect the points, okay? Now, if we wanted to, you could also have typed in where you solved for x, but you can type in the original inequality, okay? So there you have it. Notice here on our worksheet, we had an x-intercept of 4, we had a vertical line, we shaded to the right, and we used a solid line to connect our points. Okay, now when you come to the inequalities, the systems of inequalities like what we have here, you're going to type in both inequalities, okay, and then it should graph them on the same coordinate plane. Okay, so our first example here, notice we had purple and red. So purple is the first equation, red was the second equation. We had our first equation here, it had a positive slope. We used a dotted line to connect the points. We shaded above. For our red line, we had y is less than or equal to -x plus 6. We used a solid line. We had a negative slope, and we shaded below. And you can see this black region where the shading overlaps. Okay, so let's see what Desmos has to say. So let's clear out what we had from the previous example. Flip my notes page. Okay, so we have y is greater than 2x minus 3. So that was our first inequality. We've got that positive slope, the dotted line, the shading above. Okay, and then second inequality, we have y is less than or equal. And we had -x plus 6. Okay, and what we're looking for is where the shading overlaps. So it still keeps both shadings, but you can see this darkened kind of purplish green issue. This is where the actual solution to the inequality is. So you can see that for this second line, we had a solid line, a negative slope, we shaded below. For the first line, we had a dotted line, a positive slope, we shaded above, and you can see the solution right here. Okay? Now, for example 2, part B, we had 3x plus y is less than 6, x plus 2y is greater than or equal to 2. Remember, the process I want to see is I want to see you solving for y, determining your slope and your y-intercept, solid line, dotted line, testing points, that whole bit. But Desmos, you can check your result very, very easily. So let's go to Desmos. You can either clear out the old equations, the old lines, or you can just refresh your screen and it'll reload Desmos completely. Okay, so for part B, we had 3x plus y is less than 6. That was our, whoops, don't do that. Is less than 6. Okay, so that's our first inequality. You can see we had a negative slope. We used a dotted line, we shaded below. For our second inequality, we have y is less than or equal. Don't put less than or equal. I was looking at the first example. So we have x plus 2y is greater than or equal to 2. I was looking at the wrong example. All right. So you can see for that line, we had, again, a negative slope. We used a solid line to connect our points. We shaded above. And then just to be super, super, super clear, this kind of weird purplish, pinkish, blue overlapped area, that would be the actual solution to the inequality or to the system of inequalities. Okay. Two more really, really quickly. So you can see that verifies our answer right here. For part C, we had just a regular line, y is greater than x minus 1. We used a dotted line to connect those points. We had a positive slope, we shaded above. Then we had a vertical line that goes through 5 on the x-axis, and we shaded to the right of that. So let's see what we get in Desmos. So remember, in Desmos, you can just clear out the old inequalities or equations, or you can reload the whole thing. But here we had y is greater than x minus 1. So that was our first inequality. Okay. We have this positive slope, the dotted line, the shading above. For the second inequality, we just had x is greater than 5. Okay. So let me zoom out and scooch. Okay, so you can see here we have a vertical line going through 5 on the x-axis, both with dotted lines to connect. And in this case, for the second inequality, we shaded to the right, so you can see this kind of darker purplish color. That's the solution, okay? And it very much, let me actually, so if we zoom out, you can kind of see better. So there we have it, all right? And then if we go here, let's see. Well, I can kind of fit them both. Okay, so for our last example, we had y was greater than or equal to 2x minus 3, y was less than or equal to 2x plus 1. We had two lines that were definitely parallel. That means they have the same slope, different y-intercepts. Okay, but in this case, we were interested in the solution, which is all the inequalities that basically satisfy, or both, all of the ordered pairs that satisfy both inequalities is what I'm desperately trying to say. So it ends up being this little space between the two inequalities. So let's go to Desmos. And remember, you can just clear out old junk, or you can refresh the whole screen. Here we have y is greater than or equal to 2x. No, 2x. 2x minus 3. So that's our first inequality. Our second inequality, we have y is less than or equal to 2x plus 1. And there you have it. It's a little bit harder to see, so I'm going to kind of zoom in a little bit. All right, so you can see the black line was the first inequality, the red line was the second inequality. You can see here very clearly these two lines are for sure parallel, and what we're interested in is this kind of darker reddish pink color. That's the solution to this system of inequalities, okay? It's that region between those two parallel lines, okay? So there you have it. Whoops, I didn't mean to completely stop share. So there you have it. That's how you can use Desmos to verify your answers. Again, I can't say it enough. I don't want you overusing Desmos. No cheating, okay? Desmos is really just there to verify our results, okay?